Hello and welcome. I'm Barton Poulson, and this is the Data is for Doing monthly office hour. And this is an experiment. I've never done one on a Saturday, and so we'll see who can tune in. I am in Salt Lake City, Utah, in the Western United States, and it's 4 in the afternoon right here. But I want to invite you, if you are logging in, I would love to have you say hello in a comment and tell me where you are. I know a few people have registered, and strangely, I think there's one person per country. Anyhow, if you're out there, please let me know. Say hi. Also, I want you to know that this session is being recorded and it will be available immediately afterwards on LinkedIn, on Facebook, and on YouTube. And what I'm here to talk about today is I don't know how controversial it really is, but it's an interesting assertion that even when you work in the tech industry, and I'm specifically focusing on the data world, there is a very important role that soft skills play. To the point that soft skills have now been rebranded as durable skills. And I'm going to talk a little bit about why that's the case. And it's more than just a rebranding for vanity's sake. Um, but why some of these traditionally called soft skills are important to the success of a data project and data in the world. So let me bring up a presentation that I can then run through and explain a little bit about what I am thinking here. By the way, this idea is not original with me. Many people have talked about this, although I only heard the word durable skills used for soft skills within the past few months. But again, if you do a web search, you will find a lot of people talking about these things. So again, not new with me, but something that I feel is important to share with other people. All right, so let's do this. Let's have this presentation, the durable side of data work. Again, my focus is primarily on people who are working with data and the role, the critical role that these durable skills can play in the success of a data project. So let's take a look at a few things. Number one, when I talk about data work, which is a word I use in general um, in my writing, in my videos, I'm referring to collectively data analysis, data visualization, web analytics, business intelligence, statistics, data science, big data, machine learning, deep learning, predictive analytics, predictive AI, generative AI, and or agentic AI, and whatever else may be involved. The data world is really large, and so I want to make it clear that I'm including all of this. My own particular background, um, I have a PhD in social and personality psychology. I'm trained as a social science researcher. And so in my field, we use statistics to help us conduct social science research. And that's how I originally approach things. Um, I've broadened out a lot since then, but I start with statistics and I go to some of these other fields. But I think data work is a good general idea, general term for all of it. But the idea of durable skills is important to every element of this. And so it applies to all of these, including AI, even when you're handing stuff over to the machine. And I'll talk a little bit about that. Now, the obvious thing is that tools change. I've got a list here of, I don't know, about looks like 16 different technologies, starting with assembly code in 1947 to Fortran to BASIC. People were learning BASIC when I was in high school. Excel came out just in 1985. SPSS, the most common program in my field, came out in 68. I got things a little bit out of order there. But C came out in 72, SAS and SQL shortly thereafter, C++ not till 85. Python and R did not come out until the 90s. That's when I was in graduate school. These are recent things in my book. I put HTML on there from 93 because you may recall back in the 90s, humans could get jobs manually writing HTML codes for this new thing called, the World Wide Web. Um, and it was something that humans did, and knowing how to, do your brackets and pairs was an important skill. And I mention that because a person can develop real technical proficiency in something, and it's very helpful at that time. Um, I'm really good at doing certain things in Microsoft Word, but I never touch the program anymore. I was really good at working with my music in Apple Music, and I, don't really use that anymore. And so things change and tools change. And you see, my list here only goes up to 2000. Uh, so the last 25 years with the development of data science, the tech stack, the collection of technologies, applications, programming languages, environments that people use changes on a regular basis. And in fact, I had to Google it to see what the most common tech stack is for machine learning engineers in 2025, because it's different than it was 3 years ago. And there is something going on here. The idea that tools change, and even when you invest a substantial amount of time to learn how to use a tool at an effective level or a professional level, things change. I mean, really, things move fast. It's a moving target, it's a moving image, and you develop all this time and this expertise, but then things move on. And the consequence of that is that a lot of tech schools, excuse me, a lot of tech skills really become perishable skills. There's a form of obsolescence built into them. I don't know if you've ever worked with cassette tapes. Um, I mention them as obsolete because I don't even own a cassette player anymore. I mean, I don't think I do. But I used to use cassettes all the time. And not only are they perishable in terms of, we just don't use the technology anymore. I mean, if you ever had a cassette tape and you accidentally left it on the dashboard of your car in the summer, that tape itself would perish. It just get melted. And so, it was dead. Um, there is somehow a retro interest in cassette tapes. I was never a fan of them. They just made it easy to take records and put them together and make a mixtape. But the idea here is that this tech, that I know that people worked very, very hard to make cassettes, and they were a huge improvement over 8-track tapes, which I also had in my lifetime. I never purchased an 8-track tape, but we had a bunch of them in my household. In my first car, I had an 8-track player. But it's an improvement, but again, it still becomes obsolete. Even all the CDs that I bought are now obsolete. Even the DVDs and the Blu-rays that I have are now obsolete. We just don't use them anymore. Things move. And so that raises an interesting question. And that is, if certain technologies are perishable, I mean, really, what endures? This is a picture from about 2,500 years ago. And it's a picture of the Greek warrior Achilles binding a wound on another warrior, his friend Patroclus. This is from the Iliad by Homer. And I mention this in part because I actually just finished reading the Iliad a couple of days ago. The thing about the Iliad, again, written nearly 3,000 years ago, composed, spoken. It was a spoken work. The thing about the Iliad, it is generally considered the oldest work, at least in the Western tradition, that is still widely read. Uh, a few months ago, I read the Epic of Gilgamesh, which is from about 1,000 years before that, but it is not nearly widely read as the Iliad and the Odyssey. I mean, movies are made about those. People still talk about them. Elements of the stories are still very, very relevant. You can go see Brad Pitt as Achilles not very long ago. These stories endure, and trying to understand humans and their motivations and these very dramatic situations that they come up against, those things last a long time. I have technical books on my shelves that are completely obsolete, user manuals, or I have statistical manuals that refer to things that are obsolete. I have created entire courses in R, and then I learned that a bunch of the functions that I use, especially functions from early versions of the tidyverse, they're outmoded, and I have to change my code. But this idea about understanding humans and making things work on, these are things that endure. And that gives rise to this idea. The things that are now called durable skills, or really the things that are durable, the things that endure over time, are the soft skills. That's because understanding people and understanding elements of your project, those always are necessary, even if the specific technology that you're working with changes from year to year or project to project. Now, let me add one really important thing. The durable skills, the soft skills, I believe are necessary to the success of a project. They need to be there. Without them, the project will not have nearly the impact that it should. They are necessary, but to state the really obvious, they are not sufficient. You still have to have the technical skills, even though what those skills are will change from time to time. So the soft skills, the durable skills are necessary, but they are not sufficient. You still need the technical skills, but even though those skills change. Now, let me see. I can think of three different places where durable skills are going to matter to the success of a data project. And I put those areas down as analysis and project and people. And I'll explain a little bit about each of these. Now, durable skills and analysis. So the things that come up, again, these are specifically not technical skills, and these do not depend on the specific tool that you're working with, but they are things that are going to be relevant to conducting an analysis that gives you insight and makes sense. So for instance, do you want to combine different groups or do you want to take a big group and split it up? That's a judgment call that you as an analyst have to make. And that requires not do you know how to program that in a particular language or application, but should you do it? Should you include outliers or should you exclude them from a particular analysis? Again, the if you're doing this in SPSS, you're going to use different commands, and if you're doing it in R, then you're going to use different commands, and if you're doing it in Java, it's going to be different. But the decision about whether to do it and whether that's meaningful for the project, that falls more into the understanding what you're trying to accomplish and understanding how it's going to impact the results. Those are the durable skills that matter no matter what your specific tool is. How do you create constructs? That is, if you're going to take a whole bunch of different variables or fields and combine them together, how do you choose which ones to combine? Do you do a principal component analysis? How do you do a theoretically driven one? How do you combine them? And then how do you label them? Labeling factors or components was always this sort of dark art when I was in graduate school, and it makes a big difference in communication. And then how sophisticated do you want to get in your analysis, or do you want to stick to something that's simpler? There are advantages to each. I generally favor simpler, but there are ones that do simply require a more sophisticated analysis. These are durable skills. Again, they have more to do with the theory and thinking about what you're trying to accomplish, and they are not tool dependent. That's the important thing. Now, in terms of the project, durable skills in the project, so we're not thinking now about the specific how do I program this or not, but about the success. What are the research questions? If you don't know what the research questions are specifically for your stakeholders or the people who commission this from you, you're going to waste a lot of time. You're going to do a lot of backtracking. You're going to have a lot of confusion. And I've spent a lot of time working with professional analysts saying you really do need to take the time to have a series of discussions with your stakeholders to completely understand what the research questions are. And then another one is, are those questions even worth asking? I know of projects where they've developed a machine learning algorithm to perform a particular task, and my immediate reaction is, who thought that was a good idea? You are opening a whole can of worms. Why are you going there? And if you find a relationship in your data, is that relationship causal? Is it a cause and effect relationship, or is it correlational? Sometimes that distinction isn't really important if you're building specifically a predictive model and all you're trying to do is predict without explain, sure. But most of the time, people are concerned about explanation. And if you're trying to get actionable insights, you need to know whether something is causal because that affects whether you can act on it. And so causality is not a matter of data. There's not a function in R that says, causal yes or no. Causality is not a statistical question. It's a philosophical question. It has to do with the design and the inference that based on the study. And then finally, what does it all mean? And that one really needs to be in big blinking letters. What does your study mean? Why did you get the results that you did? This is the $1,000,000 question. And I know of so many studies where people have not been able to answer that one. Again, that's not a technical question. That's understanding your data. It means understanding the people who provided the data. It means understanding what went into their answers and their motivations. That's a question for the humanities, and it is also one without which your project simply will not have anything close to the impact that it should. And then the third category is durable skills and people, because people are relevant to your project. Can you collaborate with other people? Now, I do most of my work on my own, but I do often have to collaborate, certainly with the people who are asking the questions. I got to have meetings with them. If somebody else is providing the data, I have to ask what things, what does this code stand for and how did you measure this? And if I have a stakeholder and I'm going to present to them, I need to know what's important for them. Also, can you deal well with stress? Because every project is stressful. You may remember the rule of thumb that 80% of project time is spent simply preparing the data. That's an exercise in frustration. But if you don't do it well, things get confusing and there are ambiguities, and it's just hard to work with. So being able to deal with stress, the time pressure, the need to understand other people who may be communicating differently. And in fact, that brings us to the next one. Can you communicate clearly? Both in getting to understand what the project is about and working with other people, but most importantly, when you have the end result of your study or your project or the thing that you developed and you're telling your stakeholder about it, can you communicate it clearly so they know what it means and what they should do with it, and how to build on it? Technical communication is a special skill, and it's totally different from technical programming. And people need to take a little bit of time to understand how to communicate clearly with their intended audience. And then finally, can you add value? Do you understand what your stakeholders' needs are? Do you understand what their affordances are? What options work for them in terms of actionable insights? What's possible for them? What has the best return on investment? Does your analysis improve their outcomes, and does it do it in a way that's efficient? These are bigger questions. Again, there's not a button on your application that answers that question. That's why it's more important for you to try to understand the larger context in which things operate. The sum result of that is that it's not enough. It's critical. You need to have technical skills, but technical skills will never get you where you want. You need to be the complete package. You need to have the technical skills, and you need to stay up to date on your technical skills because those change from time to time. But you also need to have the durable skills. Again, the social element, the personal awareness element, the meaning making that goes into it all. Without that, you will not have a successful project. And that is the durable side of any data project, in addition to the technical side. And that is the end of my presentation. And so I'm going to come back and say, if you're out there, if you're tuned in live, please, I'd love for you to make a comment, say hello, tell me where you are. Otherwise, I'll be writing about this presentation in a little more detail in my newsletter, which is also called Data is for Doing. And following up on this theme about how you can make your data work stronger, not just by having the technical skills and staying up to date on the changing technical skills, but adding the durable skills. self awareness, the ability to work well with others, the ability to think outside the box and to add value to your stakeholder. Those are the things that are going to take your technical work and give it the full impact that it should have. And with that, thank you so much for joining me, and I look forward to hearing from you later. Bye bye.